All right. I'm Julie Peterson. I'm the extension entomologist here in North Platte, and I'm happy to participate in TAPS and do some scouting and various things with you guys in the past. But today I wanted to talk about BT trait selection. Basically, which proteins do you need in which kind of situations based on which pests you might have. So the genetically modified BT situation with corn especially started out as kind of a simple story, right? 25 years ago, in 1996 was the first year that we had genetically modified crops in the United States. And in that time, we really just had one protein and it was focused on one insect pest. We call BT crops BT because that stands for the scientific name Bacillus thuringiensis. That is this type of bacteria here. This is actually a pretty commonly found bacteria. It lives in the soil. It makes a living by actually infecting insects in the ground, in the soil, and killing insects by having them consume a protein. So the protein that kills insects, that gene is taken from the bacteria here and of course inserted into the crop plant. So then the crop plant itself produces that insecticidal protein. And of course, then when an insect consumes it, it will cause death of that insect. Now, 25 years later, this story is a little bit more complicated than it used to be. We actually have a whole bunch of these different trait packages that they're called now, and they're expressing between 1 and 5 out of a total of 9 currently different types of proteins from BT. So you can have, of course, a lot of different combinations of those proteins and how they're expressed. Each protein is really unique in its activity against insects. This is because the protein itself actually has to be consumed by the insect, and then the gut of the insect is lined with these receptors. And it's sort of a lock and key mechanism where the protein has to fit exactly with the shape of the receptor, and then they lock and key together. And that causes actually the gut of the insect to have these little holes in it. And the contents of the insect's stomach actually leak into the body of the insect, and that causes the insect to stop feeding and to die. But that specificity, that lock and key mechanism of one kind of protein having to match the receptors in a specific type of insect is really an important part about the BT proteins and how they work. These BT proteins can be crystalline proteins or cry. If you've heard that in the name of the protein before, that's how that cry gets its name. Or they can be vegetative proteins, and that's how that VIP gets its name. Vegetative insecticidal protein is what that stands for. That just refers to like the way the protein is made when it was in that bacteria. But cry or VIP is, the first part of the name of the protein. And then there'll also be some numbers and letters. And those are describing the shape of the protein itself. So each BT protein has 3 different regions. And that's sort of just how those different numbers and letters come about, is they're describing the shape of each of those 3 different regions of the protein. So my absolute favorite resource when we're talking about, right, with there being 9 different types of proteins, they're in all these different combinations and these different trait packages. The way that I use to keep that straight in my mind is I love this handy BT trait table. This is a resource it's hosted by Texas A&M University. The link is down here. And this is just kind of showing one little portion of that document, but it has the trait packages named here, has the full name and then the abbreviation. So for example, if you were looking at this bag tag here on the right, P1185AM, we know that AM there, we come over here, we can find it in our list. Okay, that has the acre max trait package in it. And then we can kind of move across the screen and see, well, that has the cry 1AB. and the Cry1F proteins expressed in that trait package. This is telling you which different insects is that product marketed for the control of. So this one in particular would have black cutworm, corn earworm, European corn borer, fall armyworm, and several other types of caterpillars. This column is really important. It shows if there have been any instances of resistance developing. Now, this doesn't mean, of course, that across the whole United States or even specific to Nebraska that this resistance occurs. It's just something to keep an eye out for. And then you could check with someone like me or your local extension folks to see, does your region have that issue? I like that it includes the herbicide trait package as well. And then it talks about the refuge. Most of what we have now is going to include the refuge in the bag, but not all of them. So of course, if there is a refuge requirement, you want to be aware of that and be able to follow that. So that is a way to use the table if you sort of already have your seed and you can see that bag tag, and then you can kind of look up what that has in it. Of course, kind of by going about it the other way, it's really, really good to think about what insect pest pressures do you have out there? And then, of course, as you're making your hybrid selection decisions, have in your mind knowing which traits do you need to have when you select your corn hybrids. So, of course, we have below ground and above ground traits. And I'll talk first about the below ground traits, right? So these are going to be, of course, targeting corn rootworm. There are actually 4 different Bt proteins, and then this new mode of action that I'll talk about that's different from Bt. It's important to realize that those first 3, they're all types of Cry3 proteins. We actually have had resistance develop, and in Nebraska, we started to see that around 2010 to 2015. So now there is quite a bit of resistance to these proteins in Nebraska. So these, I would no longer say you could use these proteins alone, especially under heavy pressure from Western corn rootworm, and expect them to be controlling your populations on their own. The Cry3435AB1 protein, we did actually just see the first documented case of resistance in Nebraska. This was in Northeast Nebraska, just here in 2021. So this protein is still working quite well across most of the state, but there are definitely some isolated patches where we are starting to see issues with this protein. Which is, I think a good, it's good then seeing all this resistance issues with Bt that we do have a new mode of action that's coming out onto the market. So this would be in products like the SmartStax Pro, and it's not Bt protein at all. It's actually using this RNA interference mode of action. It expresses this double-stranded RNA, and it targets a gene in the rootworm beetle called DV-SNF7. This is a gene that is important for the beetle to make energy. So it's a thing, if you knock out that gene, if you make it so that gene doesn't work, then the beetle will die. And that's what ingesting that double-stranded RNA does. It actually silences that gene, and then it would cause death of the beetle. So this is currently being sold as a pyramided product where it would be combined with some of the Bt proteins, which should be good for reducing resistance, but also combining modes of action, right? More than one mode of action to target that rootworm beetle. So a really important thing to think about with corn rootworm is they're really pests of continuous corn only for almost the whole state of Nebraska. There's a small exception. There's some small areas right on the border of far eastern Nebraska where there are some extended diapause of the northern corn rootworm. So that's actually where the corn rootworm beetle comes in and she lays her eggs in a cornfield, but then her eggs don't hatch the next year. Her eggs actually can wait 2 years and hatch out. So if you're doing a corn, soybean, corn rotation, You could actually have some northern corn rootworms hatching out in first year corn, but that's very isolated to just the far eastern side of the state. Otherwise, first year corn really does not need rootworm traits in it. And for taps, you guys are all going to have corn that's being planted as first year corn. It's following soybean. So there's really no need to spend any money on getting a corn rootworm trait package in your hybrids for this tap season. The only exception would be if you have maybe very unmanaged volunteer corn or a whole lot of grassy weeds like in your soybean before you plant corn then the next year. But I know folks here have been doing a good job of managing this here at our farm, so that shouldn't be a concern. Okay, next, kind of moving from below ground to above ground, thinking about which above ground traits are needed. There are 5 different types of proteins that affect caterpillars, and these are totally different ones than the ones that affect the rootworms. European corn borer is really it was the first insect that was targeted with BT, and all 5 of those proteins work quite well against European corn borer. Some other insects that we can find in Nebraska: corn earworm, fall armyworm, common stalk borer. 4 of those 5 proteins are effective against them. Black cutworm, only 2 of the proteins work for black cutworm. And then finally, true armyworm, there's really just one of those proteins, the VIP3A, that works against that insect. Now, of course, being out here in West Central Nebraska, we're going to focus quite a bit on Western bean cutworm. So caterpillar pest I haven't talked about yet. Only 2 of the caterpillar traits ever did anything for Western bean cutworm. The first one was Cry1F. This is a protein that's found in like Herculex. It's one of the proteins in Smart Stacks. We really started studying this protein though because we were really hearing from people that it wasn't working as well as it used to. We actually were able to confirm that there is resistance to Cry1F by Western bean cutworm in Nebraska. These were from 2017 and 2018 collections. We had, quite a few different sites across the western 2/3 of the state, and they were all showed resistance. So Western bean cutworm has now since been removed from the label of Cry1F products, right? The companies are no longer claiming that is an effective protein for Western bean cutworm. And all we have left is VIP3A. This is a protein that can be found in some of the trait packages like Viptera, Leptra, and Tricepta as just a few examples. And these traits, this protein, VIP3A, provides really good control for now, but we are really worried about resistance on the horizon, and we're trying to do some research to help with stewardship of this protein. So I did want to share with you all some data that we collected from the subsurface drip irrigation TAPS fields in 2020. So we went into those fields, we examined 10 ears in each plot or in each farm on August 17 in 2020. We identified any caterpillars that were found in those ears. It was mainly Western bean cutworm, but there were a few corn earworm mixed in. And we measured the amount of damage, feeding damage from the caterpillar on each ear. The scouting that we had done earlier in the season revealed about a 7% infestation rate. Now our threshold is 5 to 8%. So we did not end up doing any insecticide spraying here. And just to give you an idea as well, is we have since had even much higher pressure in these fields. Like in 2021, it was more than twice that amount. So this is sort of a medium to low amount of pressure. This is what that looks like when we collect those ears and we shuck them and we examine them for damage. You can see some areas of feeding here on tips, and some are further down on the cob, on the ear. And then you can see here's a couple of the caterpillars that came off of those ears as well. So looking at what that feeding damage looked like, this is showing the farm number across the bottom of the screen, as well as the average of all of the farms together. And again, this is from the SDI in 2020. This here is showing the square inches of feeding damage. And of course, a taller bar is going to mean that there was more injury, more feeding damage there. So these are broken down into these green bars were hybrids that farm owner had chosen a hybrid Acre Max Leptra, and that has Cry1F and VIP3A. And remember, VIP3A is the one that's like still working very well for Western bean cutworm. The blue bars had Cry1F only, and there were several different trait packages that had Cry1F only as the only Western bean cutworm protein. And then the kind of orangey ones are ones that had no Western bean cutworm proteins in them. Most of those were VT Double Pro. This is showing the percent of infested ears. So just out of those 10 ears, how many had an actual caterpillar in them when we shucked the husks off. And what you can really see is like just a clear division. These VIP3A expressing hybrids here had less than 0.1 bushel per acre yield loss caused by this feeding damage. Whereas all of these ones here that either had Cry1F or no Western bean proteins in them range from about 1 bushel per acre up to 3 bushels per acre in yield loss. Now, I said that it was sort of a low to medium amount of pressure. We also seem to have kind of low survival of Western bean cutworm in this year. So, I would expect going forward that, Western bean cutworm are going to be actually doing more feeding damage than what's shown here. But the VIP3A should continue to have, really good suppression, really good control. So here in North Platte, where we do tend to get pretty reliable Western bean cutworm pressure, I do recommend looking at those trait packages that include VIP3A, because you are going to get good protection from Western bean cutworm. So I'm really happy to take questions from you guys. This is contact information. We'll be sharing, information throughout the season. And thank you very much.